based on the diagram, at x equal to 0, this is where the temperature is at highest because due to the presence of the insulator. So there is no heat loss here. And for this x equal to 5, the temperature is lower than this part because there's heat loss to the environment. And this is where the conduction happen, and for this side is convection. Since we already know the location for the highest and lowest temperature, now we have to calculate the value of the lowest temperature first. Okay, we use this equation where heat generation times with volume equals to convection heat transfer. And then we cut off all the same dimensions and we come out to this equation. So from the equation, we can find the temperature of the surface temperature where it is the lowest temperature. Okay, after we find the lowest temperature, now the lowest temperature we're going to use in this equation for the highest temperature. But first, this is the first formula that we use, and we have to integrate twice, and then we get these equations, this one. So the delta is equal to T naught minus temperature of the surface. Now we want to find the T naught. We already find the temperature surface, and then we can get the T naught where it is highest than the temperature surface.
As you can see, this is the question given to my group. We have already done the first part of the question, which is to explain where is the plate has the highest and the lowest temperature will occur, and their values has been determined using a normal calculation method. So the second part of the question, using a software, we have to investigate the effect of heat transfer coefficient on the highest and the lowest temperature in the plate. So we use Excel in order to investigate the effect of it, and we have 5 different H used, which is from 20 to 100. So with the interval of 20 in between, so we use 20, 40, 60, 80 and 100 heat transfer coefficient value. So this is for the second part. First, we have to know the H value, our parameters. We have to set the H value, which are these values, which you can see from 20 up to 100 with the interval of 20 in between. So these are the H value we have set, and these are the values that we have to be calculated in later on, which is the lowest temperature and the highest temperature. In order to calculate the value of this, first we have to add on extra information that's already been given. As you can see, these are the extra information that's already been given inside the question and has not been changed. The heat generation, the T surrounding, which is the T environment, the heat transfer coefficient, the length of dx. So all these are given, and these are the unit of it, and this is the values of it. So first we shall try to find the Ts. So which formula we use is the one that we have already been used to calculate the manual way, which is through the first equation, E generation times volume is equals to the heat transfer using convection formula. As you can see, this is the equation used. So heat generation times the volume equals to the heat transfer using convection. And after cancelling off the similar units, we are left with heat generation times the length of it is equals to the heat convection times the lowest temperature minus the T surrounding. Since we already have all the parameters except for Ts, so we will just keep Ts as unknown and start finding the value of Ts using different values of H. In order to do that, first you have to take heat generation, which is this value, value, multiply with this value, and you divide it with h, which is this value, and then you plus this whole equation with t surrounding. And you get the answer for the t lowest and when h is 20. So in order to continue doing that until 100, the easiest way is to just drag it down. But in order for you to drag it down, you have to just add this symbol so this value doesn't changes, because the only value that's going to change is your h value. So the rest of the parameters will just remain as the same one. So D4 is your h value. So do not put the money sign over there, because you want to make sure that that's the value that's going to change accordingly. So what you're going to do after that, you press enter and you just make sure you get this symbol and drag it down all the way to 100. So you get the value until when h is equals to 100, and this is your lowest temperature that you can find. Whereas to find the T maximum, which is the highest temperature, this is the formula that you would be using according to page 106 in Heat and Mass Transfer book, equation number 273. So this is the equation that we will be used. So we use the same thing to find T max, which is your equal signs followed by a bracket, E generation, multiply with the L value, but to the power of 2, and then you bracket the whole thing first, and you divide it with another bracket to multiply with the K value, and once you're done with this, you get an answer and you plus with T surrounding. And you get your answer. For correction, you do not plus with T surrounding, you plus with TS, I'm sorry. So you plus with TS and you get your answer. This is your T maximum. So the logic is it's supposed to be higher than the TS, and currently it is. So this is how you do it. So the same way, you just have to drag it down, but the only value that changes is your E4. So in order to make sure that the rest of the value is just set, you just put the $sign at the beginning of every letters of cell that you want to make sure it's fixed. So yeah, you'll get this, and now you wait for the symbol, the plus symbol, and just drag it down and you get the value. So to check for it, you make sure your T max is higher than TS, and you're finally done with finding the value of TS and T maximum at different H value. So the next is we're going to plot a graph. So as you can see, the graph is already been plotted, which means the highest temperature and the lowest temperature, there is two lines against the heat transfer coefficient that we have already been fixed. So this is the plot of graph that we have already been done based on different values of H, TS and T maximum. So as you can see, as the heat transfer coefficient increases, the lowest temperature as well as the highest temperature decreases as well. This is because when the heat transfer coefficient is higher, when the heat transfer coefficient increases, it means it has higher potential to transfer heat. So when you consider it has higher potential to transfer heat, so the efficiency of heat transfer is higher. When the heat transferred is better from the surrounding, from the surface to the surrounding, it means that there is higher difference in the temperature change. That means the temperature that would be on the surface, or the temperature that would be as the maximum temperature, would be lower because more heat is being transferred through convection.